This is part one of a four-part video series. In this video, we're going to talk about the lateral surface area of a cone. Here's a cone. We're calling the length of that side L, and the radius of the base is R. And what I'm interested in is a formula for the lateral surface area. When I say lateral surface area, I mean just around the sides. So I don't care about that base, that circle on the bottom of the cone, just the area around the sides. So let's imagine that we cut open this cone. If we cut open the cone and flatten it out, right? Imagine the cone's made out of paper and we cut it open and we flatten it out. We're going to be left with almost a circle with some little wedge or a little sector cut out. The L that we see along the side of the cone is now the radius of our circle. And let's call this angle theta. Okay, what I would like to calculate is the area of the sector of that circle. So the area of the sector is a fractional part of the area of the whole circle. What's the fraction? The fraction is theta over 2 pi. It's a fractional part of the area of the circle, pi L squared. Now, assuming that I know this sector comes from the cone above here, I know what L is, but I don't know what theta is. So I need a formula for theta. So let's look at the relationship between the cone and the circle. The circumference down here, this circumference, is the same thing as this arc length. You see that? Because I cut open the cone, so the circumference of the circle at the base of my cone is equal to the arc length around this circle. And the circumference at the bottom of the cone is 2 pi r. And the arc length here is a fractional part of the entire circumference. So I know that my 2 pi r is the same thing as a fractional part, theta over 2 pi, of 2 pi L. What were we looking for? We were looking for theta. So let's try and isolate the theta. The 2 pi cancels with the 2 pi. I can divide both sides by L and I get that theta is equal to 2 pi r over L. Let me plug that theta in way up here in my formula for the area of the sector. Go back to blue, area of the sector, which remember is the same thing as the lateral surface area of the cone. Whichever way you want to think about it, that's equal to theta over 2 pi, which is 2 pi r over L over 2 pi times pi L. And now let's clean that up. This 2 pi cancels with the 2 pi. The 1 minute, I didn't write that right. It's pi L squared. I knew I was missing something. Okay. The L here cancels with one of those L's, and we get the surface area of the cone is equal to what's left? The pi, the r, and the L. Pi r L. That's the surface area of the cone, and we'll be needing that in part 2 of this video series.